All right, let's have a look at practice quiz number 1. Question number 1 says a 1.95 times 10 to the 3 kilogram car traveling north at 72 kilometers per hour. What's the magnitude of the momentum? Spelled wrong, but that's okay. You know what I meant there. Hey, listen, this is a fairly straightforward question, but there's something that could lead us to a little bit of a silly mistake here. What is that? I want to draw attention to things that are going to lead me to a silly mistake, especially when I've got a quiz or a test. Things that I can circle, okay, underline, highlight, whatever. What is it that could lead me to a silly mistake here, Colton?
Meters per second, not kilometers.
Yeah. We want to convert kilometers per hour to meters per second. So I'm going to circle that, draw attention to that, and then I'm going to convert that right away to meters per second. 72.0 kilometers per hour is the same as 72,000 meters per 3,600 seconds, which is 20.0 meters per second. What's a shortcut that we could have used to find that velocity in meters per second instead? What's the shortcut? Yep. Divide by 3.6. So I don't care which way you do it. Multiply by 1,000, divide by 3,600, divide by 3.6. The second way is a tiny bit quicker, but we're not worried about speed here, right? I told you, you got 6 hours to write this diploma exam. Speed is not a factor. You're going to finish this exam. If you take an extra 15, 20 seconds doing something that makes more sense to you, that's okay. That's not going to cause you to run out of time on the exam. All right, so we've got a mass here. We've got a velocity here. This is just a pretty straightforward question at this point. Mass times velocity is 1.95 times 10 to the 3 kilograms times 20 meters per second. If you were to forget to convert that, my guess is that that option is there. Is it? If you forget to convert it, it's A, right? So clearly, we have to draw attention to it so that we don't forget to convert it, because this is a quiz or a test. We don't convert it, we're going to think we have the right answer, right? We're going to walk out of there confident that we have the right answer. What does that end up being? 3.9, I think it is. 3.90 times 10 to the 4, is that right? Right? Yes? Okay, so the answer is D. Notice it asks me for the magnitude of the momentum, not the momentum. Momentum includes the direction, but if we're only asked for the magnitude of the momentum, then we're not looking for the direction, which is good, because we couldn't find a direction given that we don't have a direction given to us for the velocity. Number 2, a 145 gram baseball is moving at a speed of 27 meters per second when it's 2.5 meters above the ground. What's the momentum the instant that it strikes the ground? This is one of those momentum after acceleration questions, right? 12G, momentum after acceleration. What do we want to draw attention to here? Some little thing that could lead me to a silly mistake. This happens a lot, right? Is your hand going up there, or are you scratching? Yeah, it's grams to kilograms. We're going to divide that by 1,000, right? I'm going to say my mass is 0.145 kilograms. What else we got here? Thomas, tell me something else that I have given to me here. Tell me something else that I have here. What's this 27 meters per second thing? Yeah, it's velocity. Specifically, it would be VI, right? The initial velocity. It's the first time we've had one of those momentum after acceleration questions where we've had a VI, right? I told you we want to be ready for those, right? But this is the first time I think that we've had that. What is this 2.5 meters thing? What's the 2.5 meters? Yeah, I'm going to call that displacement, but if I do call it displacement, I'm going to make it negative 2.5. If I called it HI, that would be okay, but I find more people like calling it displacement. Then we're going to, HI would be positive, D would be negative. We're looking for PF here. Final momentum is mass times the final velocity, but we got to find that final velocity. And I think we're going to do this. BF squared is BF squared is equal to BI squared plus 2AD. It seems like we use this equation a lot in these questions, but don't think that you necessarily have to. Any of those physics 20 acceleration equations are valid here. It doesn't matter which one fits the givens the best. In this one, it seems like it often does fit the givens the best. Okay, we're going to go VF squared VF is the square root of VI squared, which is 27 squared, plus 2 times negative 9.81 times negative 2.5. Now, I'm going to put a second set of brackets in there. Some of you, depending on your calculator, need the green brackets. Some of you don't, depending on your version of the calculator. Let's calculate that now. Let's go. Everybody do this? Well, you know you've already done it. So if you got the right answer, it's all good. You don't need to do it again. I'm going to go square root, green bracket, 27 squared, plus blue bracket, 2 times neg 9.81 times neg 2.5, and the blue bracket and the green bracket. I get 27.8935. Now we're only looking for the magnitude of the momentum, which is usually what happens in one of these questions. So we don't need direction. We're just going to say 0.145 kilograms. 0.145 kilograms times the final speed, which is 4.04. The answer would be B. I just noticed, actually, that should be 4.0, shouldn't it? Final answer should be 2 digits because of the 2.5 thing. 3. Which of the following units are correct units for momentum? That would be Newton seconds. Newton seconds is for momentum, kilograms meters per second, but also Newton seconds works. Question, this should be number 4, not 3, but whatever. This is a tricky one, I thought, actually. I had to kind of think about this one a little bit. This wasn't directly from class. Got to think a little bit about this. Maybe take a little memory from physics 20 there. 2 kilogram cannonball is fired into the cannon at an angle of 30 degrees to the horizontal. When the cannonball reaches the top of its path, this is the momentum, 800. What's the horizontal component of the ball's momentum, the cannonball's momentum, when it left the cannon? Who thinks they have an answer for this? Yes, Stein, what do you say? B? Oh, B. Same as it is there. Christian, what do you say? Oh, you also said B. It's 2 to 0 for B right now. Anybody else say something different? Yeah, the answer is B. You're right. Good. Think about that, guys. Horizontally, what force acts on the cannonball as it moves through the air horizontally? Gravity acts vertically, right? So that's going to cause it to slow down as it goes up and speed up as it goes down vertically. But gravity isn't going to change its horizontal motion, is it? There are no forces acting on this cannonball horizontally. And if there are no forces acting on it, it's not going to speed up or slow down. And if it doesn't speed up or slow down horizontally, it does vertically, right? But not horizontally. If it doesn't speed up or slow down horizontally, velocity horizontal remains the same, then the momentum horizontal is going to remain the same. And if the momentum horizontal is 800 right here, well, then the momentum horizontal is going to be 800 here and here and here and here, everywhere, including at the very beginning of this. The horizontal component of the cannonball's momentum when it left the cannon is the same as the horizontal component when it's at the top. Does that make sense, you guys? Not crazy hard when you have it explained to you, right? Just tricky, at least I thought, tricky before you have it explained to you. You really had to think about that one. And number 4, really it's number 5, I guess. The last one, a 1,200 kilogram car traveling north at 20 meters per second collides with a 1,000 kilogram car traveling south at 24 meters per second. The total kinetic energy and the total momentum are what here? Hey, tell me one thing that could lead me to a silly mistake in this one. And I'll give you a hint, it's not a unit conversion thing. Does it say? Yeah, the north and the south. I'm going to actually put positive for north and south for negative just to remind me about that. Let's calculate the total momentum. M1 V1 plus M2 V2. M1 is 1,200 times 20 plus 1,000 times negative 24. I'm not going to forget that because I drew attention to it, right? I guess I was looking for kinetic energy first, but whatever, it doesn't really matter. Bracket 1,200 times 20, and the first bracket plus second bracket 1,000 times negative 24 gives me 0. 0? How can the total momentum be 0 when two things are moving? Is that possible? How can the total be 0 when it's when we got two things that are moving here? Yeah, one guy's moving one way with a certain momentum, the other one's moving the other way with the same momentum, but opposite directions, so they add up to give you 0, sure. Okay, so that means the answer is either going to be B or D. Let's find the kinetic energy now. 1/2 m1 v1 squared plus 1/2 m2 v2 squared. M1, 1,200. This one's not going to be 0, is it? The kinetic energy will never be 0 if something's moving. It can't cancel out. It can't, ever. Because kinetic energy is a scalar, and there are always going to be positive values, regardless of the direction. Now, V1 is 20. We're just not paying any attention to the direction there. What do you get when you do the math on that one? Is it 4.8? Is it 5.2? 5.28 times 10 to the 5 joules. So that means the answer, I guess, would be B. B.